Welcome to Easy BTech, your guide for BTech and beyond. Students, in the last class, we have discussed what are the rectifiers and how the different types of rectifiers are there. In this session, we clearly studies what are the parameters of rectifiers, what is its efficiency, all those we will calculate. Okay. Rectifier parameters. Okay. That all we will discuss here. Now first, if you take a half-wave rectifier, first parameter is average value, or IDC. Okay, IDC is equal to 1 by T integral 0 to T I dt. Therefore, we know that current I is equal to Im sin alpha between an interval 0 less than alpha less than pi. I is equal to 0 between an interval pi less than alpha less than 2 pi. This is from yesterday's session. This is the current for an half-wave rectifier. It conducts only 0 to pi. Pi to 2 pi it does not conduct. By substituting that equations here, IDC is equal to 1 by T. Time period, it is a complete cycle. This is a incomplete cycle. 0 to 2 pi. 2 pi integral 0 to T means 2 pi. I means this. Im sin alpha. Again, this also write in terms of d alpha. Okay, students, if you want to substitute this interval, IDC is equal to 1 by 2 pi integral 0 to pi Im sin alpha plus pi to 2 pi. Pi to 2 pi interval, the current is 0. This term is 0. Okay, students, to find out the average value, the formula is IDC is equal to 1 by T integral 0 to T I d alpha, where IDC is equal to 1 by 2 pi integral 0 to 2 pi Im sin alpha d alpha. And by substituting that current equation for an half-wave rectifier, you will get this expression. We will get, after substituting that interval, we will get IDC is equal to 1 by 2 pi. Now the Im is a constant, remove out Im integral 0 to pi sin alpha d alpha. This is an interval. Now you can substitute. IDC is equal to 1 by 2 pi Im integral 0 to pi, this sin alpha d alpha. Okay, integral of sin minus cos. Integral of sin alpha is minus cos. Im by 2 pi. You can substitute here. Minus cos alpha, interval between 0 to pi. Now you will get Im by 2 pi minus, you can remove this minus outside, minus cos higher interval b minus a cos pi minus cos 0. Okay, we know that Im by 2 pi here minus cos pi minus 1 and here cos 0 minus of cos 0 1. Now we will write this expression as minus Im by 2 pi into minus 2. This minus minus it becomes plus. We will write Im by 2 pi into 2. This minus and this minus becomes plus. 2 will get cancelled and we will get the value Im by pi. Okay, this is the IDC value. Average value of half wave rectifier. Average value of half wave rectifier is Im by pi. Okay. Similarly, if you want to calculate VDC is equal to IDC into RL. We will write IDC means what is the function? IDC means Im by pi into the VDC. VDC is equal to IDC into RL. That is, we will write VDC is equal to Im by pi into RL. From this we will write VDC is equal to this Im by pi, Im into RL can be written as Vm. We will write Vm by pi. This is the average value of a half wave rectifier. Students, just go through this. Next, RMS value, IRMS or IAC. Formula for this is root mean square value, root 1 by t integral 0 to t mean square I square into d alpha. This is the formula for that IRMS. We will write IRMS is equal to under root 1 by 2 pi integral 0 to 2 pi I means already we know that Im sin alpha whole square into d alpha. We know that for half wave rectifier 0 to pi the value is Im sin alpha current. For pi to 2 pi current is 0. Now by equating that IRMS is equal to under root 1 by 2 pi 0 to pi Im square sin square alpha d alpha plus pi to 2 pi it is 0. Okay, no need of writing that equations. Now we will write this under root 1 by 2 pi integral. This Im we can make constant, remove outside, Im square by 2 pi sin. Now we will write from the formula, that is cos 2 theta is equal to 1 minus 2 sin square theta. theta you can assume as alpha. Now from this you will assume, if you want to write sine square theta, we may write this 2 sine square theta is equal to 1 minus cos 2 theta. If this 2 removes, it will come bottom. Means in the place of sine square theta, we will write 1 minus cos 2 theta by 2. If alpha, we write sine square alpha is equal to 1 minus cos 2 alpha by 2. The same we will write here. Integral 0 to pi 1 minus cos 2 alpha by 2 into d alpha. We'll substitute that expression. Im square by, this 2 will come out, 4 pi, interval 0 to pi 1 into d alpha minus integral 0 to pi cos 2 alpha d alpha. Okay students, see these expressions. Now next we will write IRMS is equal to under root Im square by 4 pi integral 1 d alpha is nothing but alpha 0 to pi minus cos 2 alpha, integral of cos is sine 2 alpha, with respect to alpha we will write 2, an interval between 0 to pi. Okay, substituting these expressions under root Im square by 4 pi into, in place of alpha you can substitute the interval pi minus 0 minus sine 2 into pi minus sine 2 into 0 by 2. Now you can see here Im square by 4 pi minus this sine 2 pi is 0 minus sine 2 into 0 sine 0 sine 0 is 0 by 2 it is 0, this term is 0. Okay, now here from these expressions this pi will get cancelled, we will get Im by 2 whole square root get cancelled, so you will get Im by 2. This is the IRMS or IAC value. IAC value of half wave rectifier is Im by 2. Similarly, if you want to write a VRMS, that is IRMS into RF plus RL. All right, VRMS is equal to IRMS Im by 2 into RF plus RL. This we will write VRMS is equal to Vm by 2. Okay students, this is the way we are finding the values for average value and that is output DC and input AC IRMS values we are finding for the half wave rectifier. Now we can calculate all the parameters. We know that IDC is equal to Im by pi. Second parameter IRMS or IAC is equal to Im by 2. Okay, this we know. Now if you want to calculate the next parameters, that is form factor. To calculate the parameter for form factor it is defined as, it is a ratio of RMS value to average value. It is a ratio of RMS value to average value. That we will get, what is the RMS value? Im by 2 by Im by pi. So Im will get cancelled. We will get the value is pi by 2. That is 3.14 by 2. So approximately we will get 1.57. Okay. The form factor for half wave rectifier is 1.57. Next, ripple factor. Okay, to calculate ripple factor, RMS value of AC component by average value, that is RMS value IRMS square minus IDC square. This we'll call as a by IDC. This component is RMS value of AC component. Okay. Thus this we will write as ripple factor is equal to under root. If you make common here, we will write IRMS by IDC whole square within the root, it is minus 1. This we will write as under root IRMS value Im by 2 minus Im by pi whole square minus 1. This is under root pi by 2 whole square minus 1. This value will get approximately 1.21. The ripple factor of half wave rectifier is the ripple factor. Okay, ripple factor is 1.21. Next, efficiency, percentage of efficiency, that is PDC by PAC into 100. Output power by input power, that is output power to input power into 100. Percentage of efficiency is equal to. Now we will write PDC. What is PDC? PDC is equal to, in terms of power, P is equal to V into I. We write voltage in terms of current, that is I square R. V is equal to IR. We will write in this. PDC we will write as IDC square into RL. and IAC square. IAC means RMS, that is IRMS square into the forward resistance, that is RF plus RL into 100. This is efficiency. We will write IDC. IDC is Im by pi whole square into RL by Im square by Im by 2, that is 4, okay, into RF plus RL. This we will write into 100. This we will write Im square by pi square into 4 by Im square. Im square will get cancelled into RL by RF plus RL into 100. This we will write as 4 by pi square into 100 RL by RF plus RL. This we will get 40.6. If you calculate the value, the efficiency of off-wave rectifier is this 4 by pi square numeral. The numeral of 4 by pi square. Pi you may take 3.14. By substituting that, you will get the value of percentage of efficiency. Next, peak inverse voltage. Peak inverse voltage of off-wave rectifier is Vm. Means what is the reverse voltage withstanding when the diode is reverse bias, that is Vm. Next, ripple frequency. Ripple frequency is F. These are some parameters of off-wave rectifier. What are those? We will see the chart here for an off-wave. First one is average, that is IDC value is Im by pi. Next, IRMS is Im by 2. Next, third, peak inverse voltage is Vm. Fourth, ripple factor is 1.21, no units. Fifth, efficiency, percentage of efficiency 40.6 RL by RF plus RL. 6, form factor 1.57. These are for the parameters of off-wave rectifier. Okay, in examinations you may calculate in this manner, students. You just go through this. And you may have another parameter that is also same like efficiency we will calculate. Tough transformer utility factor, it may be 28%. Transformer utility factor for off-wave rectifier is 28%. It is simple. PDC by PAC into 100. You see transformer utility factor, that is PDC by PAC into 100. This we will write VDC into IDC. Next VAC into IAC. These values, by substituting these values, you will get. And the root mean square value, we have to take the value, that is VAC is VM by. The only change is VAC or VRMS we have to take as an VM by root 2. By substituting that, you will get the value transformer utility factor 28%. Okay students, today we will discuss next topic, that is parameters for full wave rectifier. Parameters for full wave rectifier. Now you can see here, same, the first parameter is average value, I average or IDC. This also same, 1 by t integral 0 to t I into d alpha. Okay students, we know that therefore the current through the diode I is equal to Im sin alpha, and the current between 0 to pi and pi to 2 pi is minus Im sin alpha. That you can substitute here, 1 by 2 pi integral 0 to 2 pi, I means Im sin alpha d alpha. So you will write 1 by 2 pi, Im is constant, bring out Im, 0 to pi Im sin alpha plus pi to 2 pi minus Im sin alpha. Okay. This one is equal 1 by 2 pi. Here Im is there. Now you may choose, if you take Im constant, then you may write 0 to pi sin alpha, but we are including the Im inside, we may write it like this, 1 by 2 pi 0 to pi Im sin alpha and pi to 2 pi minus Im sin alpha into d alpha. Here also d alpha. Now we will write 1 by 2 pi, here Im will come out, integral of sin minus cos alpha d alpha, cos alpha d alpha with an interval between 0 to pi. Here minus, again integral of sin minus into minus, it becomes plus cos you'll write cos 2 pi, say cos 2 alpha, sorry, you may see here integral, here you write, here minus is there na, here minus, and integral of sin is minus into minus, it becomes plus, right, cos alpha interval between pi to 2 pi d alpha. Now remember the cos. Okay, here you are getting minus, here you are not getting, here you are getting plus. What expressions you will get here? Same, Im by 2 pi, IDC is equal to Im by 2 pi, this is minus cos alpha with an interval 0 to pi plus cos alpha pi to 2 pi. Okay, substitute that interval inside. Now Im by 2 pi minus cos pi minus minus cos 0 plus cos 2 pi minus cos pi. I will get Im by 2 pi. Here you will get cos pi minus 1, minus of minus 1 minus cos 0 1 plus here cos 2 pi 1 minus cos pi minus 1, minus into minus plus 1. Now you can write Im by 2 pi, this value is 2 minus 2 minus 2, this minus plus 2 plus this 2, it becomes 4. You will write IDC is equal to Im by 2 pi into 4, 2 ones, 2 twos. You will write 2 Im by pi. IDC value is 2 Im by pi. VDC value is 2 Vm by pi. This is the value. Okay, students, average value of a wave rectifier. Average value of a full wave rectifier it is. Average value of full wave rectifier. Similarly, we will take RMS value. Same root mean square 1 by t integral 0 to t I square d alpha. Now we will write under root 1 by 2 pi integral 0 to t 2 pi Im square sin alpha square alpha d alpha. By substituting the value, I is equal to Im sin alpha. I is equal to minus Im sin alpha. Where it is a square, it never shows any, because minus 1 whole square is 1 only. Like that, I square na. Within a square, the value of minus it becomes plus. Now, while you are substituting under root 1 by 2 pi integral 0 to pi Im square sin square alpha d alpha plus pi to 2 pi Im square sin square alpha d alpha. Now we will write under root 1 by 2 pi. Here Im square will take common all. We will write integral of 0 to pi. Sin square we will write in the previous we have seen sin square alpha formula is 1 minus cos 2 alpha by 2. We will write 1 minus cos 2 alpha by 2 d alpha plus pi to 2 pi 1 minus cos 2 alpha by 2 d alpha. This is the expression. Okay, students, now we will see IRMS is equal to under root Im square by 2 pi. Here you can see here Im square by 2 pi. Now here we will split integral 0 to pi, all this you can split it, here 2, here 2 will come, it becomes 4 pi. Okay, we'll see. By making common, it will becomes it becomes 4 pi integral 0 to pi 1 d alpha minus integral 0 to pi cos 2 alpha into d alpha plus integral pi to 2 pi 1 d alpha plus integral pi to 2 pi cos 2 alpha d alpha. From these expressions we will write im square here 2 here 2 will common, we will write im square by 4, and here integral 0 to pi 1 d alpha minus integral 0 to pi cos 2 alpha d alpha. Okay students, now we will write this IRMS is equal to under root this im square by 4 pi. Here we will write pi minus 0 is pi minus, you can see here 0 to pi integral of sine, here minus integral of sine cos. So integral of it is cos, integral of cos is sine 2 alpha by 2 with an interval between 0 to pi. If you substitute, this value is also becoming 0 because sine 2 pi 0, sine 0 0, plus here also we will substitute by substituting here this value integral of pi to 2 pi 1 d alpha is alpha. In the alpha you can substitute the interval pi to 2 pi, you can simply write as an higher integral is 2 pi minus pi, you will write as a pi, plus this term is also 0 again, you will write sine 2 alpha, here also minus not plus, sine 2 alpha by 2 interval pi to 2 pi, this term is also 0. Now we will write IRMS is equal to under root im square by 4 pi, here we have pi and here you have 2 pi minus pi, you are having 2 pi, here you will get pi will get cancelled, 2 ones 2 will get cancelled, we are having IRMS is equal to im square by 2 within the root. Simply we will write root and square get cancelled, we will write im by this root 2. Okay students, this is the value. What is the IRMS value? im by root 2 is the value. Okay students, using these two parameters, average value of full wave rectifier is im by 2 im by pi, and IRMS is im by root 2. By taking these parameters, we will calculate the remaining. First, form factor RMS value to average value, RMS value im by root 2 by average value 2 im by pi. Now here im will get cancelled, we will write pi by 2 root 2, pi by 2 root 2, this is the value we will get for the form factor, approximately 1.11, by this you will get this numerical value you will get. Next, fourth, ripple factor IRMS by IDC whole square minus 1, that is under root IRMS square, that is Im by root 2 whole square by 2Im by pi whole square minus 1. By substituting this value, you will get this Im square get cancelled. Okay, what you will get? Under root this you will get pi square by root get 2, and it is 2 square 4 to 8, pi square by 8 minus 1. This you will get 0.485 like this. This is the ripple factor for full wave rectifier. Ripple factor and ripple frequency. Ripple frequency is 2f. Peak inverse voltage. Peak inverse voltage for it is also Vm. Okay, that we will derive a chart now, students. See here, that is parameters. Next, half wave rectifier, full wave rectifier, that is center tapped, and bridge, all are same. Okay, students, first average value for half wave rectifier is Im by pi. For this is 2Im by pi. For bridge rectifier is also 2Im by pi. Next, RMS. Value. IRMS value for half wave rectifier is Im by 2. Here is Im by root 2. It is Im by root 2. Next, form factor. Form factor for this is 1.57, 1.11, 1.11. Next, ripple frequency. F, 2F. Peak inverse voltage, Vm. For this bridge rectifier, that is center tapped, two diodes are there, two different voltages. Okay, one during the positive half cycle in upper is a positive, and during the down, because in a center tapped secondary transformer is equally voltage divided. During a positive half cycle, D2 is a reverse bias, and during the negative half cycle, D1 is a reverse bias. That is why peak inverse standing 2 times. That is why we will write 2 Vm, peak inverse voltage of center tap rectifier. Next, efficiency. Efficiency for this is 40.6. It is 81.6. Same how we are calculated in this. How we have calculated the efficiency for half wave rectifier. In a similar manner, we can calculate for the full wave rectifier. Okay. Next, efficiency completed. Ripple factor, very important, 1.21 ripple factor, and for this is 0.485. Next, the last parameter, that is transformer utility factor. For this is 28%, for this is 69%, for this is 82%. These are very important in exam point of comparison of rectifiers. Comparison of rectifiers. Okay students, in the today's lecture we have discussed all the rectifier parameters. I hope you understood well. Easy BTech guide for BTech and beyond for your easy understanding. Thank you.